My name is Vetri Vel, and for my research I developed a real-time fall detection system using thermal imaging and deep learning. And my motivation was I heard many instances of older adults falling and not getting help for hours. And you can imagine how agonizing this would be. While there are commercial systems, they have issues. And in the case of medical alert pendants, older adults often forget or prefer not to wear them and may be unable to use them if injured after a fall, or if they fall from something like low blood pressure. As an example, my neighbor's elderly mother removed the medical alert pendant before going to church, and then forgot to wear it after returning, then fell and broke her hip and couldn't call for help. And only the next day did people check on her and she had to be admitted to the hospital. And this is actually a big problem because over a quarter of older adults and half of the oldest adults fall each year. And quick assistance is critical after a fall, reducing hospitalization by 26% and death rate by 80%. But unfortunately, in over 20% of cases, the individual remained falling for over an hour before getting help, because many of them live alone. So when designing my system, I set constraints and objectives and chose components based on this. So I used deep learning to classify thermal images on a Raspberry Pi microcomputer to detect falls. And for example, the thermal camera met my constraints of maintaining privacy and working in the dark. And the Raspberry Pi allowed for it to be wall-mounted, low cost, and able to call for help over the internet. So here you can see the system functioning in real time. But first I had to train it. So I collected thermal images of people in normal postures, fallen, and non-human heat sources. And then I isolated heat source in the image by looking at histograms of pixel values, and you can see the background pixels form the spike. So I set the threshold above the spike and all the values below the threshold to 0. So once I had just the higher pixels, I looked at connected regions to get the region of interest masks, and then I picked out individual features. And these extracted features were used to train a convolutional neural network, or CNN, to classify them as fallen, normal, or non-human. And a convolutional neural network works by applying filters across an image before feeding the resulting maps into densely connected layers of nodes. And the filters can specialize to detect things such as edges. And in neural networks, the weights that connect nodes and the filter coefficients are parameters that are randomly initialized and can be trained or repeatedly adjusted, often using an algorithm called backpropagation. So when I trained the CNN, I often got an accuracy of 140 testing features, all of them correctly classified. And this was promising, and I found that the architecture with one convolutional layer and 3 filters had the highest average accuracy, so I used it going forward. And then I introduced pets into training and testing data, and I got an average accuracy of 98.6%, which is still pretty high because it has to distinguish between humans and pets. And also I tried introducing a different body type to the testing data, and actually didn't decline at all, even though it was trained with a different set of images from a different person than it was tested on. And I also changed the number of training images, and I found that a minimum of 200 was necessary for a high accuracy, but the system can be pre-trained so the user wouldn't have to collect this themselves. And here you can see how it segments images and classifies them in real time, with green for normal, blue for non-human, and red for fallen. And this allows the system to track and classify features in real time, and I use it to quantify movement and reduce false positives. And here you can see on stairs, I tried fall detection, but there was a challenge of the railing separating regions that should be together, but the preliminary accuracy was still above 95%. And finally, in real-time fall detection, the system continuously captures images, and if the person goes from a normal posture to fallen, and then remains fallen and doesn't move for a set period, the system can call for help by sending a text message to a list of contacts. And I think this system could mean the difference between someone lying on the floor for a day versus getting help in 10 to 20 minutes, which improves the safety and independence of older adults living at home. And I made the system open source in GitHub with all the programs and instructions, so anybody who wants to can implement it. And this means it's a one-time cost for the hardware. But going beyond fall detection, the system is versatile and can be used for other applications, such as monitoring if an autistic child wanders at night, or seeing if an older adult with Alzheimer's wanders out of their house. And my methods are generalizable, so it can be reprogrammed for this. And I'd like to stress that this system is especially important during pandemics, where older adults may not get the help they need after a fall because they're more isolated at home or in assisted living facilities and people cannot check on them as much.